Hi everybody, in the previous video we've seen how transactions unlocking works on the database level. We've seen that you can lock rows either by selecting them for update or by updating your row, and there is no way to unlock rows in SQL or Oracle, so the rows will remain locked until the transaction is either committed or rolled back. Now let's look how all of this is handled in the migrated code. So here we have the Northwind project and we have a very simple products program. Let's go and play with its transaction settings and later with locking. To determine the transaction used in a controller, there's a property called transaction scope. And we can choose the scope we want to work with. In this case, we're going to use the task scope, and we'll explain the several scopes afterwards. Of course, you can read about it in our documentation in fireflymigration.com/reference, and here is the documentation for transaction scope, where we can see the different scopes of transaction. Currently, I've chosen the test scope where we can see that the transaction will begin before the start event and end after the end event. Let's see this in action. So I'm going to run our code, and we have our program, and now we have a transaction. Okay, let's pause our code. I'm going to use the Shift F12 shortcut to break us into the code, and we can see in the watch window the in-transaction property that actually indicates whether or not we are in a transaction. Now let's go ahead and add some breakpoints and see what happens with that. I'm going to put a breakpoint here, here. Let's add on start and on end. And I'll put some breakpoints here and here. As we run our code, we can see that we are not in a transaction before the controller was not yet executed. When we step to the next line of code, we'll get to the on start, and we can see here that the transaction is already happening. And as we proceed, the application would run and transaction is still on. When we'll exit the screen, the transaction is still on because we are still in the on-end event, but if we proceed through the code, okay, we can see that the transaction was changed to off once we exited the controller. Another way to better understand transaction is to have a look at what goes on with the database. So to do that, we're going to set the debug property in the debug properties here to say yes. This means that any interaction with the database is going to get written to the output window. And we're going to do the same thing over here. Let's put this on the left. Okay, and run the product screen. And now we can look at the output window. We can see the select statements that went to the database. We can see the connections that was opened and the transactions that has begun. Okay, you can see the begin transaction for when the transaction begins. If we scroll through the rows, nothing will change here. Only once we exit the screen, we can see the commit transaction going on. Great. Now let's change the transaction scope to row to see a difference. Using the row transaction scope means the transaction scope will begin before the enter row event and will end after the row was saved to the database. So let's add an on enter row, on leave row, and on saving row, and see what happens with all of these events. First of all, let's have a look at the output window. We'll open the product screen. We can see that the select statement has happened, and as we move along, we don't see any indication of transaction. Why is that? This is because we're not actually opening a transaction until we have to run some kind of SQL statement. If we break into the code, we can see that in transaction is true. We are in a transaction, but at this point, there was no point in opening the transaction because there's no select statements or any operation to do within the transaction. Perfect. Let's review it with debugging so we can see exactly the breakpoint that we're talking about. I'll put a breakpoint on start, on end, on enter row, leave row, and saving row, and see what happens with the transactions. So on start, there is no transaction. Later, when we enter the row, a transaction is valid. When we leave the row, the transaction is still valid. Enter row, again, transaction is valid, but it's a separate transaction. If a transaction had to be opened, you will see it as a begin transaction. And if I leave the screen, enter row, leave row, sorry, note on still a transaction, and when we reach the on end, the transaction was changed to false. Great. So we have several scopes of transaction, as we've said. The most common one is task, row, and row locking. Row locking actually would happen according to the locking strategy of the specific controller. Let's have a look at that. Let's activate lockings. Let's take away all of the breakpoints. And let's activate locking. To have locking, there is an enum called row locking, where you determine the locking strategy of a specific row. And there are 4 options. None is the default, no locking in this controller. On row loading, okay, let's go find the documentation for it so we can see exactly what it means. We'll go to the row locking property, and we look at the locking strategy enum, and we can see on row loading, a lock will start immediately after the row is loaded. Saving is when it is being saved, and on user edit happens when the user makes some kind of change. Let's see how that works. So we say on row loading. We'll say also, setting this property is not enough to activate locking. We need to say which entities take part in this locking. So other than cache, we'll say allow row locking equals true, and that means that this entity, together with the property here of the row locking, will be part of our locking. Let's run this and show the output window. Wait. Open the screen and let's see what happened. We can see here that the select statement was issued to the database to get all the rows. And we can see here the settings for execute reader, select with, update lock, no wait. This is actually the locking statement. And we can see also the begin transaction right before it. So remember, our transaction scope is row. A transaction scope is set to on row loading, to row, which means that for every row there will be a separate transaction. And row locking is set to on row loading, which means whenever I'll enter the row will get locked. Now, since the transaction scope is row, whenever I leave the row will be released. So let's see over here, let's clear the log. When I go to the next row, first we'll see the commit transaction of the previous row. We'll see the select statement for locking for the current row. And as we move through it, we'll see release and lock, release and lock. Let's look how that works from the SQL Server perspective. Remember, we created in the previous video this nice select statement that shows me which rows are locked. So when I'm parked on row 1, we can see that row 1 is locked. When I go over to row 2, we can see that row 1 is released and row 2 is locked. Now, if I change the transaction scope to be task, and do the same thing, we'll be able to see one begin transaction, the select statement, and one lock row for the row we are on, where product ID is equal to 1. If we go over to the SQL query parser, we can see that the first row is locked. If I go to the second row, we can see that the first and second row are locked, and if I go to the third row, we can see that all 3 rows are locked. Once I exit the screen and the transaction gets committed, we can see that all the locks were released. So far for this video, we'll pick it up in the next one, explaining more about task hierarchies and other subtleties around this behavior.